All right, so last class we started working on our linked list class. Okay, so our linked list class will keep three properties going. One is the length, or in other words, how many nodes will be in this linked list. And then we have two references, one to the start of the list, the head, and one to the tail. So these are references to nodes that will be created. Okay? Now, when we construct a linked list, it's a little different than constructing an array. When you construct an array, you say this is how big you want it to be. But the whole point of the linked list is we don't say how big we want it to be. It should take up no space until we need space. So what we're going to do here is wipe out anything that could be there. So in other words, it'll be the length is 0. Right? That's when we construct a linked list. The length is 0. The head is null. We don't want it to actually be a node yet. And the tail is a null. Now remember, null is basically a spot in the computer's memory that keeps track of no actual location. So it's useful for just setting it to be no memory at all. Now if you feel like being a little bit fancy, you can actually reduce this down to one line by doing this. Head equals tail equals null. That's like saying x equals y equals 10. Both of them will be 10, right? So that just means the same thing. It just saves a line of code. Okay? What you couldn't say is length equals head equals tail equals null, because length isn't going to be a null. It can be set to 0 because it's an integer. But head and tail are both nodes, so they can both be set to null in one line. Doesn't matter. You can keep it as 3 lines if you want. All right. Now, we're going to be writing toString, and we're going to be writing equals. We're going to get to those eventually. Okay? But instead, what I want to do is write a couple little methods right here at the start that'll be helpful down the road as we get into this linked list. One is, it'd be nice to know when this thing is actually empty. So we're going to make a public Boolean method called isEmpty, no parameters. And it's going to return true or false if the list is empty. Now, based on the 3 properties we have, how do we know when the list is empty? Any idea? Is it empty right now? It's empty right now, right? And it's empty when the length is 0 or the head and the tail is null. Now, for this, we could make a really complex if statement. So actually, don't type this, but if you just watch, I could do this. If length equals 0 and head equals null and tail equals null, then I would return true, that this is an empty list. Otherwise, I'd return false. But this seems like a lot of code that I don't think I need all of this, if you think about it. Do I really need to do all of this to determine if it's empty? I could do all this, but I really don't have to. First of all, do I need all 3 parts of this if statement? Really, I just need one of them, right? If I code well, I could maybe just check the length. Okay? So I could reduce it down to that. But wait, I can go further. This is a pretty simple if statement. So I don't, for example, need the curly brackets. It's just one line. So I could, I could theoretically do this. That makes it a little bit smaller. Okay, but wait, I'm not done yet. This is a method, and anytime you return from a method, the method's over. So in theory, I don't even need else. I could also just do this, right? That would also work the same. If the length is 0, return true. And if it does that, it's over. But if it's not over, then it'll hit this one. And the last thing I want to show you is actually the one I'm going to suggest you type in, and it's what the light bulb's going to suggest to us. It's going to say that this if statement is redundant, because in theory, you can actually reduce the lines down to just this. Now, I wouldn't show you this in grade 10, but if you think about it now, just think about what this means. Just that. What is the result of that? If I say length equals 0, what are we thinking about there? That is either a true statement, length either equals 0, or a false statement. That's what it is, right? Length equals 0 is like we put inside of an if statement, is either true or false. So when it says return this, That's what it's doing. It's skipping that sort of middle step. Now I get it that that isn't necessarily the easiest code to follow, but it's certainly short right there. Okay? It's certainly a short piece of code that checks to see if the length is 0. I wanted to put that into our example just to show you that you can reduce your code in terms of length of lines, but that doesn't necessarily make it more understandable when you do that. Okay, but this is a good one, I think, to try that in, just to see how short we can make our code. All right. So that's a simple one, is empty. Here's the next one that's going to be simple. We're going to keep track of the length of this list, which is how many nodes it is, but we encapsulated that and made it private, which means outside the class, we can't access this length. Now, maybe at this point I should imagine an example here. So let me first start with an array. Say we made an array A equals new int size 5. Then we went, okay, A spot 2 equals 10, and we had a for loop. And we said A dot length. That's how we would work with arrays. That's nothing that we didn't know already. We learned that last year. Here's what I imagine it's going to be like with our linked list. We're going to make a linked list. I'm just going to call it list equals a new linked list. Oops. And we're going to use a constructor there. Unlike up here where we use square brackets, we're going to construct a linked list. We don't have to say how big it is. It'll be as big as it needs to be. And then from our list, we'll call methods to, for example, set a spot and things like that. So it won't use square brackets, it'll use methods. And one of the methods we might need will be a method like this for looping. We'll need to get at the length. But we made length private. Well, that seems silly, but we did that because then people can't do this. They can't change the length. We don't want them to be able to set the length. We only want them to read it. We don't want them to change it. So we want an accessor, not a mutator. So we're going to do that by keeping it private and now writing a little method, public int method, and we're just going to call it size. And all size does is returns the length. So this is how we are now creating an accessor for this property, but you can't mutate it. You can't change length. You can, it's a simpler way to put it is it's read only. You can only read length. You can't change it. So now from back here, what we could have done is, oh, if we want to know how long this list is, we'd call list.size. And that would give us the number, but we can't change it. We can't assign it a new value. Okay, that's good. So construct the linked list, make it empty. We're going to write one more. Well, we're going to write lots more, but this one is an interesting one. It's a void method called finalize. Now, finalize is a Java term. In C# they use a different term for this. But this is a method that's often called when you want to wipe out something. Okay? So if we think here, so say we did a whole bunch of stuff with the linked list and then we wanted to just wipe it out. Finalize would be something you would call in that case. And really, what does finalize do? Well, it does the same thing the constructor does. So we can steal those 3 lines from the constructor, pop them into finalize. Oh, well, if we do that, why don't we just call finalize from our constructor? Just to shorten that up, too. We can do that as well. So now the constructor calls finalize. Finalize is what sets everything down to nothing. Now, you'll notice the light bulb has appeared with finalize. Okay? Because very much like toString, finalize is actually something you can override. So finalize is built into the object class as well. Okay? But there's actually one other thing the light bulb suggests to you. Because finalize is kind of this sort of finality thing that's happening, There's actually something else you can do to a method here, and I want to use this as a teaching tool. If you add this keyword in a method, which you normally, where do we see that keyword normally? Final. We've seen it before, that keyword, but where? The keyword final, where do you normally see that keyword? Yeah.
Oh, yeah.
Constants. Yeah, with constants. It's the Java word that C# uses const for. It means, and with a variable, it means you can't change it. Well, with this keyword, what it means, when you put it into a method, it means it cannot be overridden. So if we ever have a class that inherits linked lists, like this thing extends linked list, you can't override finalize because it's been locked away. It's just a fun little fact there. But it's just a way to sort of, I just wanted to add that in there as something interesting in your notes. Okay, so that's pretty good. We can now create a linked list, check if it's empty, check its size, and wipe it out if necessary. So why don't we apply this to our test right now? We can't do a heck of a lot with the linked list, but let's try a little bit of code at this point. So we made some nodes. Now let's make a linked list. Okay. Now, when you type that code in to your testing class, you will have to import this, but I want you to be cautious here when you import it. There are two options at the top. One is to import it from your collections package. That's what we want to do. But you'll actually notice that there is already a linked list class that you can use, and it's built into what's called the utility package, or util, which is inside of Java itself. So it's not, doesn't come by default, but if you want, you can import that one. Well, we're not going to learn anything if we import that one. The whole idea is we're writing our own. But I just want you to be sure which one you import. So go import collections.linkedList. That should mean at the top here it says that it's importing from your library, not the utility library. Not that there's anything wrong with that one. That one's probably a better one, but we're learning how to do this, okay? Now, because we're using generics, right here we have to define what the data type is going to be. So what do you guys want to make our linked list of? Integers, strings, booleans, doubles, persons, whatever we want. What's that? Yeah, longs. Could be huskies. But the problem, I don't want it to be too complex because we're going to do things like output it, right? And we don't want to sit and wait for a giant output. So why don't we go with strings? That's a good suggestion. Let's make it a linked list of type string, and we'll just call it the list equals a new linked list. And at that point, you can also put the diamond right there for this. Oops, maybe you don't put the diamond there. What's going on here? Ah! So, we didn't put generics into our linked list. I just realized that. So let's do that. Data type T. Linked lists will also use generic type T. My apologies, we forgot to do that. So now, that should clear that up. Okay? So now our linked list will be a list of strings. Okay? Maybe we should call this list 1, because maybe we'll make another one. Yeah, let's call it list 1. Why don't we make 2, just for fun? And then let's make a list 2, but pick a different data type. How about doubles? Damien suggested double. That's a good one. Remember, the best way to work with this, though, is of data type class. So when we say double here, use capital D. So it's a class type, not just a generic data type, like a primitive data type, pardon me. We could make more. We could make them of integers, et cetera, but that should be good. So one's of string, one's of doubles. So at this point, I can go list1 dot, and I have the methods available that I have. So is empty, size, toString. We know if we call those, it's not that useful right now. Okay? But the lists are ready to go. Okay. So the first thing we're going to need to do, if we're going to use these linked lists at all, was already outlined for you back a couple classes ago. I said, at minimum, okay, our linked list should do the following. So I'll just review that list. Our linked list should be able to add stuff into the list, remove stuff from the list, change, mutate, and access things in the list, and travel or traverse the list. And I said as well that this gives two advantages right away over the array, because with the array you can't add and remove. You can change and access, but you can't actually add and remove once you set the size of the array. It's locked in. So we're going to have to do that. We also talked about that adding is a little more complex. Do we add to the front, the back, the middle? When do we delete one? Do we delete them all? There's lots of different options there. So let's start with the simplest option. Okay, in our linked list class, let's write a method to add to the front of the list. Okay, so it'll be a public method, and it's called add front. And what we're adding is some data. Now, we don't know what the data type is here in the linked list. We know in our example it's strings, but here in the linked list it's generic. It's just data type T. Okay, before we go and write this code, and it's about 6 lines, it's not much code. I'm going to ask you this question. Does this method have to be void? And if it's not void, what data type could we return from this? Okay, so we're saying here add, like here, let's imagine we're using it. So whoops, go to our, let's do this right now. Let's add something, even though the method isn't finished yet. Let's add something to list 1. Let's go list1 dot add to the front. Let's give it a string. Random word, please. Dog. Okay? So we're going to add that to the front of our list. And let's do one with list 2. List2 dot add to the front. Can I have a random double, please? 1.4. Double. 32.1. 32.1. Okay. There we go. So that's how we'll be using the method, right? That's how we'll be using it to add that to the front of the list. And let's do it again. Let's do it twice. So then list1 dot add front. Another random string, please. What? Random word. Random word.
77, but spelled out.
And for list 2, a random double. Aaron, random double, please. 64.4. Okay, there we go. Now, if we think, we could keep going, but that's enough for now. Let's imagine what's going to be happening. What's going to be happening is, when it sees this, it's going to go, oh, okay, dog will be placed inside of a node, okay? And the head of this list will be the dog. And because it's only 1, the tail of this list will be dog. And my count that I've called length, which is just a little integer, will now go to 1. That's what should happen. Okay? When it calls it the second time right here, it will then create another node. Into that put 77. But now what's going to happen is the tail is going to shift over to here. Or no, sorry, not the tail. The head is going to shift over. So this stuff's going to kind of move around. Hang on, let me do that. And dog. And the tail's going to go there, like that. That's what's going to happen. Plus, these nodes are going to link together. So this is going to link to this. This is going to link to this. This one's going to be linked to null. And this one's going to be linked to null. And every time we add to the front, another new node will go in the front, and the head will shift over. That's what will happen. And this length will go up each time we add one to it. That's what we want to have happen. That's the code we're going to write. Okay? But the question is, should that return something? What would add front return? I'm going to suggest we could make this method a Boolean method. Often methods like this are Boolean. Why would it be Boolean? Peter? Yeah, if it was successful or not, right? Sometimes we want to think that way. It's easier to debug later if you can figure out whether it actually did add it or not. So the true or false, was it successful or not? So let's write it this way. Okay, here's how we add data to the front. The first thing we have to do is make a node. So node equals new node. Now, the other thing about this node is we're using generics. So one thing we're going to have to do here at the front is put data type T there. Again, we don't know what the data type is, but it's going to slide over to our node class and expect the same data type. So there we go. Node equals new node. Okay. And we'll put that. And then one thing we can do with that node is we can put the data in there. We can say node.data equals data, right? Because data is a property of the node class, and this data is our parameter, right? So we took our parameter and stuck it into there, right inside the node class. You okay so far? Question, could we do that in one line? Peter?
You just pass the data to the constructor.
Right. Remember we built all those different constructors? Well, let's use one of them. Let's skip a line of code here by just taking this line out and just putting data right there, which means it'll call this second constructor right there. Now it picks up the data, passes it along to our final constructor down here, and it goes, oh, okay. The past data gets put into this, and the other two things get set to null, which is perfect. That's what we wanted it to do. Okay. So that'll be our first line of this method. Construct that node. So remember, what happens with this line, and we put into this, we put the word dog in our example. So what it did is it builds a node called node with a lowercase n. Through the constructor right here, it puts the word dog into the data part of the node, and it sets this to null and this to null. Remember, what these three things are is this is data, this is next, and this is previous right here. Okay? So you with me? That's what that line just did. This line creates node. All right. Now, if this is the very first time we're doing this method, the way we run it will be different than every time after that. Because if you remember, when I drew that, it was easy the first time. I just went, oh, dog. This is the head. This is the tail. Done. Okay? But when I added a different one to the front, one of those things had to shift. So let's start with the easy one first, adding it for the first time. Well, that will happen if this thing is empty. If it's already empty, then I'm adding it for the first time. And there's where that little method comes in handy. If it's empty, okay, then what I do is I set head to be this new node and tail to be this new node. Or can I do that in one line? That's right, you got it. Head equals tail equals node. You got it. That's another way to do it. Just again, if you want to shorten it up. So that's if I'm adding for the first time. If I'm not adding for the first time, that's when an else comes into play. So this means I'm adding a node for the very first time. This means every time after that, which could be the second time all the way up to like the second billionth time that I'm adding it. Okay. Now we'll leave else for a second. And after the else, one other thing's going to happen, whether it's first or second. The length of this thing has to go up by 1. And that's going to happen whether I'm adding the first node or the 500th node. The length, that's why I've kept that outside the if statement, because it's going to happen no matter what. I could put it in both the if and the else, but why bother? It happens no matter what. Okay, here's where learning about linked lists and understanding how when I'm going to draw diagrams really helps. Okay, so let's imagine it happened for the first time. So dog, I'm going to draw this a little more carefully. Okay, dog was inserted into this node. And that's a null, and that's a null. Okay, remember this is the data, this is next, this is previous. Okay, that happened for the first time. Now I'm calling it again, and it was 77 the next time. So what we want to have happen is another node is created. which is going to happen. It's going to make another node right here called node. Okay, and in it, it's going to put 77. Okay, this is a null, this is a null, this is data, this is next, this is previous. Okay, but there's two other things going on here. Hang on, I just got to make some more white space because you're going to get lost in this for a second. So, there we go. Okay. Sorry, I just wanted it nice and white. Okay, so there's what we have right now. But remember, there's two other things in play here. There's something called head, and it's right there. So the way you can think of head is it's a reference to that first node. There's also something here called tail, and it's referencing this node. But this is the one we just built. So using words, tell me how I should properly, what kind of things I need to do here to get that node connected to the rest of the list. Just use your own words. What has to happen here? Okay, because this is really the only part of the list we have right now. We just built this node, but it's not connected yet. How do we connect it? Okay, so tell me what I need to do. The data's in there. The data's in there. But this thing needs to change right here, right? Yeah, this thing has to connect to here, right? That's one thing we have to do. What else do we have to do? Do we have to do anything with this node? Because this should not be a, whoops, this should not be a, that thing should be gone, right? It should be not a null anymore. But what about this one? Yeah, previous, this thing here. That has to go, and we have to also do this. That's another thing we need to do. Is connect it there. Is there anything else we need to do? So that'll connect it into the list. Move head, that's right. This has to slide over to here. That's the third thing we need to do. We need to do those three things, not necessarily in that order, but we need to make this connected, and shift head back. Okay, I'm going to give you the code to do that. But I wanted to just save this picture here for a second. I think there's a way to do this. Capture ink. Can I just paste it directly in here? Nope. Send to a new page in Smart Notebook. There we go. Oh, yikes. Okay, well that worked. Sort of. All right. So now I'm going to clear this. All right. Here's the lines of code. You guys ready? Node dot next equals head. Okay, so let's stare at that for a second. Node dot next equals head. This is what node is. Node is the brand new node we built. So which number did I just perform? 1, 2, or 3? Node dot next equals head. Because what I did was number 1. Because remember, head hasn't moved yet. Head is still back here. I know in the diagram it's not. But I just did number 1. I said node dot next equals what the head is. So that's what I did right there. Okay? Now the next line I'm going to type after that is head dot previous equals node. Head dot previous equals node. All right? So we've already taken care of 1. Did I just do number 2 or 3? Which operation did I just perform? 2 or 3? Right. You're on the ball today, Damien. 2 is correct. Because remember, this is currently head right here. So don't forget that for a second. This is head right here. So I just said head dot previous, that's this thing, equals node. Oh, that's that thing. So I just made that connected right there. So I'm using code to tell it how to connect stuff. Now I just need to do number 3. And all I do for that is I say head equals node. That performs my third operation. I just said head, hey you you should be equal to what node is. So it just moved it over to there, which is what I wanted to do with part 3 there. So in those 3 lines of code, I actually connected it into the list. Okay, so hang on. I can tell this is probably foggy. So I'm going to show you how this works again. Okay, so if you can indulge me for a second. So I'm going to call this with 3 pieces of data. So I know that I'm going to feed it the word dog. Then I'm going to feed it the word 77. And then another random word, please. Nothing too long for me to write. Cat. Okay, so let's say those are the 3 times it's called. Okay? First of all, when the linked list is built, head and tail are null. They're not set to anything. Right? That's what our constructor says. Also, okay, length is currently 0. Okay, so this is our linked list right now. Head, length, tail. So I call it for the first time with the word dog. It comes to the first line. It says, okay, let's make ourselves something called node right here. So it makes something called node. And remember, this is the data. This is next. This is previous. Oh, when it makes it, it puts the data inside. Oh, okay, so the word dog is automatically put inside. And also, according to our constructor, it sets this to null and this to null. So it goes check. If it's empty, oh, it is empty. So head points to this thing called node, and tail is connected to this thing called node. Check, was able to perform that. Skips the else and does this line. Okay, length goes up to 1. Completed. I've now added dog into the list. All right. So that's so far working. Okay. Let's get this. Oh, so much to move. All right, so there it is. Dog's in there. Oh my gosh, that's taking forever. And there's head. Okay. Can I rotate this thing? No, never mind. Okay, it's good enough. Okay, now it calls it with 77. So it starts off with this line again. Makes a brand new node called node. Okay. And actually, this is a good point, so let me just finish this up. Puts 77 in there. Okay. This is previous data next. This is a null. This is a null. Okay, so it makes that node. Now, here's where students sometimes get confusing. Isn't this one called node anymore? No, it's not. Once the method's done, that name for it doesn't exist anymore. So this thing is basically anonymous now at this point. Okay? It's not called node anymore. Now this one is called node. That's the new one. Okay? It's like, you know, when you have a teacher and he calls you partner, and then all of a sudden you walk into the next class, and he's calling somebody else partner. I'm his partner. He can't call anybody else partner. I'm the partner, right? Even though you guys are all still my special little snowflakes. It's possible that maybe I have other special little snowflakes in other classes. All right. You can be my special partner, yeah. All right. Now, here's where it comes down to the if statement. Is if it's empty. Well, it's not empty anymore. Length is not 0 anymore. So it skips this line. It doesn't do this. It comes down here to these lines. Okay, so here's where it goes. It says node. That's this thing. Dot next means this thing. Node.next means I'm talking about this thing. It says it's equal to what the head is. Oh, so it says this thing isn't what it is anymore. It's now going to connect this to head. And this is head right here. Head is this thing. Okay? So that does this line right here. Then it comes to the next line. Head, that's this thing. Dot previous. Oh, it means it's talking about this right here. It's not that. It says head dot previous, you are equal to node. Oh, that's this thing. So that's how it made those two connections. So it went, oh, okay. I've accomplished this task. Then the final task, it says head, that's this thing, you need to be equal to what node is. So it now moves head over to node right there. that's how it does it. And then the last thing it would do is increase this by 1. Okay, and that's how it linked it in. Now I'm going to go through it quickly one more time, because now I've added 77. Now I'm going to add cat. So once again, it starts at the top. It builds a brand new node called node. Into that, it puts the word cat. This is a null. This is a null. Done. If it's empty, it's not empty. So now it comes down to here. It says node, that's this thing. Dot next, that's this thing. Okay? Oh, sorry. This is no longer node. See how easy I am to use this? This is no longer called node anymore. Okay? This is now called node. So node.next means this thing. Node.next equals head. Oh, okay. Connect this thing to the head. Done. Node or head.previous equals node. Well, this is the head. This is the previous, so it's this thing it's talking about right here. Oh, man. So it connects this to node. And then head equals node just shifts the head over to this new node, and it's added that one. And then one last thing, it just increases this to 3. So that's the process. Now, I want to go through that kind of slow because it's all about references. Now, if this was a void method, we'd be fine. But because we said we're going to return a Boolean, we have a couple little last things to do. So after length plus plus, if I get all the way down to here, I'm going to return true. I was able to successfully add this to my list. How would I not be able to add this to my list? Yeah, if I ran out of memory space, but that's a hard thing to detect. One thing I think I could do is I could error check this data. What if that data is a null? What if they tried to add a null to the list? I should not allow that. So how about I add a little if statement at the very front of this? If data equals null. Let's get out of here. Return false. So that's a quick error check to make sure that whatever I'm trying to add to the front of this list is not nothing. If I try to add nothing, I just don't do it. And the rest of this code doesn't work. If it is something, then I'll go through all the process of doing that. So it's just a quick error check at the front, just to make sure that the data I'm adding isn't garbage, isn't nothing. Okay, this is also in the notes with an animation. So here it is. Now this one I made a void method, so it avoids that little if statement. Ours is a little bit better. So it makes the node, okay, and for every subsequent node, it inserts it in front of the other one on the list that way. All right. So let's see then that that should work. It should be adding that stuff. So if we can add to the front of this list, we can also do the exact opposite. We can add to the back of the list. So here's my advice. Rather than rewrite all that code, copy this whole method, add front, paste it underneath, and let's just change the word front to back. And let's think about what needs to change. So if you understood the last one, we can go through this and see if some of this code will stay the same. Okay, do you think this line should stay the same? If the data equals null, return false. Should that also happen at the back? Yeah, okay. So we'll leave that line alone. Should we still be making a brand new node and putting the data in it? Yeah, so that line should stay. If it's empty, and it's the very first time I'm adding it, should I set both the head and the tail to null? What do you think? So I'm adding the node for the first time. It's going to the back. Is it the same as adding it to the front? Is it the same logic? Yeah. So all of this is fine. It's the else part that I think we need analysis for. Because we're still going to increase the length by 1, and we're still going to return true. It's those 3 lines right there. Like these lines are okay. But it's these 3 lines that we need to actually analyze. Peter.
Why?
Okay, but hang on. Those are the 3 we need to actually look at. So the rest of the method is the same. It's just those 3 lines that maybe we need to figure out if they're correct. So this is assuming that there's a list already in place. So let me just draw a list for a second here. Okay, cat. I know that wasn't the first one. Dog. Whoops. Actually, it should be going to the back. So I'm going to leave a space here for where that new node's going to go. So let's say we had dog here. Okay, this connects to this one. This one connects to this one. This is connected to null. This is connected to null. This is the tail. Do we care about the head when we're adding to the back? The head could be way up there, right? It could be way up in the front. We don't care because we're adding to the back now. It's the tail that matters. Okay, so we've just built also a new node right here called node. And let's say the data we were inserting was the word rat. Okay, so we just put the word rat in here. And this is a null, and this is a null. So that's the code we have. This is what we want to have happen. So first of all, we're not dealing with the head anymore. So in these two places, or three places, we put the word head. Let's change that to the word tail. Because we know we're dealing with the tail. Tail, tail, and tail. It's not about the head anymore. It's about tail. Okay. So now I said node.next equals tail. That's not right. That's not what's supposed to happen. It's not node.next equal. To make that connection, what should it be? Right, so let's change this word next right here to previous. Okay? So that was able to accomplish this task. Node.previous equals tail. Perfect. Now, this next line, tail.previous, that's this thing, equals no. What should it be? It's not tail.previous, that's this thing. Remember this? Yeah. It's tail.next, that's right. So let's change that to next equals node. Okay, so that was able to accomplish this connection. This now is connected to here. The final line was tail equals node. Is that right now? Yeah, that's fine. Tail equals node. Done. So adding it to the back was just reversing that logic a little bit. Perfect. Okay, let's imagine we called that. So list1.add to the back. Can I have a random word, please? Juniper. And list2 dot add to the back. Can I have a random double, please?
17.6.
Okay. I'm going to do a psychoanalysis on you kids, how you pick these words and numbers. There might be a pattern there. All right, dog 77 juniper, 32 64 17. I don't know. All right. We can now add to the front and add to the back of our linked list. It's hard to tell if this is actually working because we can't see our linked list at this point. So I think before we go too much further into this, it might be nice to actually display our linked list to see if this is working right. And let's do that by taking a minute to write the toString method of our linked list. Because then we can output it. If we go back to here to testing, what we can do then is go sout, system out, list1. Well, list1 dot toString. Turn it into a string, and let's output it. And the same with list2. Because it would be great if we could output what these linked lists look like to see if what we've just tried actually worked, if it put them in the right order. So if we do this right now, and then we try to run the toString method, you notice what it'll do is it'll call super toString. What's the super class of linked list? Right, object. So if I play this right now, it's going to run the toString method of the object class. And if, as you recall, we did this in the last unit, all it does is output the memory location, which is not useful to us. So I'm running it right now just to show you that that's the case. But we want to write a more useful toString method that overrides that one. Here, look. All it did is it gave us some weird memory address right here. That's not good to us. We don't need that. Okay, so let's write a toString method for our linked list class. You guys ready? All right, so we're going to start off with an if statement. If this list is empty, then why don't we just return the words empty list? Let's just return those words. Okay. Okay, and this now can go. So it's just an if-else statement. If it's an empty linked list, we'll just return the words empty list, and then we're done. Okay? But if it's not an empty list, let's start up a string of text. Okay? And I'm going to use a bracket like that, just to go on one side or the other. And at the end of this, I'm going to return that text plus the closing bracket at the end. And obviously in the middle, I'm going to fill it up. I'm going to fill that text up with a bunch of stuff. And to do that, I'm going to travel through my linked list and fill it up with all the content. Yeah, I deleted that. That's correct. Okay? So it's now just that. So I'm just going to play that, and I should see those two brackets now. There we go. See there? It's not right, but it's at least not returning that memory address anymore. It's overriding the toString method. Okay, let me pull back a bit. I think I'm going off screen here a little bit with you guys. Okay. Need a minute? Liam, you okay?
Yeah.
Damien, you okay? Okay. What you're going to see now is the code that's generally used to travel through a linked list, or I'm going to keep using the fancier word traverse a linked list. The way it's generally done is we start off by a node called current, and we don't make a new node. We don't need a new node for this. We say current equals what the head equals. So what current is, it's a reference, and it starts off at the head. Now, we don't have to start at the head. We can also start at the tail, but we're going to travel it the more common way, starting at the head. And now we can use a while loop. While current is not equal to null. Because we know with null, we've hit an endpoint. Okay? So the while loop rather than the for loop is used here, because with for loops we have an exact count, right? With while loops we can just keep going until we reach that null point. What we do is we say that text equals what the text was plus what's in current. Now current is a node, right? So what we can do with that is say current dot toString. We'll turn the current node into a string, and then attach to that a comma, just so it's a separator between each thing there. Now if you want, you can shorten this instead of text equals text. Does anyone remember the shorthand for that? Plus equals, right? That's the same as text equals text plus, so that's a way to do it. But that's still not, we have one more line inside the loop. And this is a line you're going to get familiar with linked list. You say current equals current dot next. Now if you analyze that line of code, what it means is it advances current over to the next node. Now I'm going to draw this for you in a second, but let's just see what this actually does now if we play this. So that's now our toString method. If I play it, 77, dog, juniper. 64.4, 32.1, 17.6. Now, did it do it in the right order? Is that the way we set it to do it? Let's see. Go back to my test here and run it again. Wait a minute. Dog was at the front. Then we added in front of that 77, right? 77 got added in front. And then juniper was added to the back. So that's right, right? Now, if we called add front again, it should go in front of 77, right? Like, we have to think about how it's getting added and in what order it's getting added. So we can add to either end of this linked list. Now it's already kind of cooler than arrays. We could have this in a loop all the way up to 1,000,000, and it would just keep adding things to the front and back, right, as much as we need it to. Okay, let's analyze this toString method just for a second. Well, that's what we'll call it a day. So let's assume we had the list that we just said it was. So it was 77, dog, and what was the other one? Juniper, right? That's the way we assume this thing is designed, like this. Dog over. There we go. Okay, so we assume it's connected like this. This is connected to this. This is connected to this. This is connected to null. We assume this guy's connected back to here. This guy's connected back to here. This guy's a null. We assume this is tail. We assume this is head. That's what we assume we built in our linked list. Here it comes to toString. It says, okay, I'm going to make myself a node here called current. Current equals head. So it looks just like that. Current looks just like head. Well, current is not a null. Well, it's not a null. Current's pointing to something. Text equals take what's in this, add it to the text. Okay? Then current equals current.next means this thing equals what the next thing is. So it basically shifts that over to there. That's what that line does. Current equals current.next. Then it goes back up the loop. Is current to null? No. So add that to the text. And then move current to the next again. Add the text in there. Then move it to the next. Now when it does it the last time, current.next is here. And that's a null, and that's when it leaves the loop. Okay? So we'll continue this tomorrow. It's a little tricky looking at linked lists. They're all about references and all about diagrams.